On May 30, 2016, President Xi Jinping stated at the National Science and Technology Innovation Conference, "Advancing into the depths of the Earth is a strategic scientific and technological problem that we must solve." Vertical shafts, as crucial engineering structures for developing underground space and resources, serve as the shortest passage connecting the surface and underground spaces. Traditional shaft construction methods, such as drill and blast and freezing methods, are increasingly unable to meet the growing demands for safe and rapid shaft construction. There is an urgent need to develop full-face shaft boring machines that integrate tunneling, support, and muck removal functions to meet the requirements for safe and efficient construction of ultra-deep shafts. The 1,000-meter hard rock vertical shaft TBM has a total height of about 60 meters and a main unit power of about 2,000 kilowatts. It consists of a cutter head, shield, support shoe system, main drive, propulsion system, anchor drilling rig, formwork system, vertical belt conveyor muck removal system, mud circulation system, auxiliary equipment, high-pressure water jet system, electrical system, hydraulic system, bucket muck removal system, derrick, surface winch system. Simultaneous operation of tunneling, muck removal, and formwork support. The full section cutter head, under the combined action of the main drive system, propulsion system, and support shoe system, rolls and crushes the rock mass. The W-shaped cutter head causes the rock debris to gather at the lowest point under gravity, and then it is scooped up by the bucket wheel excavator bucket and enters the slag collection area of the slag discharge belt conveyor in the center of the cutter head. The rock debris is then vertically transported to the slag bin by the vertical belt conveyor. The bucket moves to the slag bin receiving port under the drive of the winch. The rock debris in the slag bin is unloaded into the bucket and lifted to the outside of the tunnel by opening and closing the gate. The rock debris is then unloaded on the slag discharge platform of the derrick. Finally, the rock debris is transported to the spoil disposal site by slag trucks. During tunneling, the rock drill is driven by a motor to move to the designated position. The drilling angle is adjusted by the swing motor, and the rock drill rotates and propels to complete the drilling operation, enabling normal drilling perpendicular to the tunnel wall. After one cycle of tunneling is completed, reinforced concrete is installed, the formwork system is in place, and then concrete pouring is carried out to achieve the purpose of shaft support. During tunneling, the gripper shoe tighten against the tunnel wall, providing reaction force for propulsion. The propulsion cylinders extend, driving the main drive and cutter head downwards. After one stroke of tunneling, propulsion stops, and the propulsion cylinders and support shoes are retracted sequentially. The entire machine is then lowered one stroke, the same as the tunneling stroke, via the ground winch suspension system. The support shoes are then fixed back in place, completing the step-by-step operation of the main propulsion system. The propulsion cylinders and winch suspension system are divided into 4 groups: up, down, left, and right. During tunneling, the stroke and pressure of the 4 groups of cylinders, along with the lifting weight of the winch suspension system, precisely determine the overall tunneling direction. Rock braking function. When encountering extremely hard rock, greater than 200 megapascals, the efficiency of the cutter head rock braking drops sharply, and the cutter wears out severely, resulting in slow tunneling efficiency. The equipment is equipped with a high-pressure water jet system with a water pressure of up to 300 megapascals. The high-pressure water can cut circumferential joints in the rock mass in advance to achieve a certain rock breaking-free surface. Auxiliary slurry mode tunneling function. A full-face shaft boring machine is equipped with a slurry pipeline muck removal system on its main body. In the event of sudden water inrush, where dry mucking is no longer feasible, the system switches to the auxiliary wet muck function. Through a pre-installed submersible slurry pump located in the cutter head, water and rock debris are conveyed together to the rear auxiliary screening system, where large particle rock debris is separated out and then hoisted by bucket. The auxiliary muck removal can also serve as emergency drainage, with a maximum drainage capacity of 250 cubic meters per hour. Advanced geological exploration function. In addition to radial anchor bolting, the configured anchor bolt drilling rig, through its targeted cutter head and shield design, enables advanced geological exploration, ensuring that every excavation must be explored and knowing oneself and one's enemy, thus guaranteeing that the equipment is aware of the geological conditions ahead during excavation and can formulate reasonable construction plans and excavation parameters based on the specific geological conditions. Supporting treatment functions for adverse geological conditions. Full-face shaft TBM may pass through various adverse geological conditions during deep well excavation, such as uneven hardness, fault fractures, and water inrush in the strata, posing construction risks such as water inrush, collapse, and localized surrounding rock deformation. This equipment is equipped with a retractable cutter head, shield body, and a winch suspension system to lift the entire machine, thereby improving the ability to handle adverse geological conditions. The excavation never stops, and the progress is endless. Building on its successive development of medium and ultra-large diameter full-face shaft TBM, CRCHI has joined forces with research institutions, design institutes, and construction units to address the needs of underground resource development, achieving a powerful alliance that makes ultra-deep shaft construction safer, more efficient, and more intelligent.